here is our lecture content video for today. We're pretty much just going to be, my brain dead, doing some exam review before your guys' exam tomorrow. Again, it's between 5 and 7 p.m. except for those of you who have talked to me already. And yeah, that's it. Good luck. So let's see here. All right, so I'm just going to jot down some things that I think are important that you guys know. We did already do an exam review, and I hope you guys have been reviewing on your own. But these are just some key points I wanted to go over. Okay, so the first one is know how to determine where a graph is continuous So are you able to find a discontinuity? And then also differentiable graphs. So finding where a graph is not differentiable. So basically where you can and cannot take a derivative. So if we were to look at an example here really quickly, let's say we had something like this. And we'll have it continue here. Okay. So if you guys were to tell me where things are not continuous, it's right here. So that is a discontinuity. And then if you were to find where things are not differentiable, a discontinuity means something isn't differentiable, and also wherever we have an abrupt change, so like a point in our slope. So here we go instantaneously from a positive slope to a negative slope, and it doesn't go to like a zero slope. This point here is not differentiable. So things are not differentiable at points and at discontinuities. Okay, hopefully that's all pretty clear. Next is just taking derivatives in general. So all we do in this class is take derivatives, so I hope you guys are comfortable with it. Let's go over, I guess basically the rest of this review is just taking derivatives. So let's see here, just like a regular derivative example. Let's say we had the derivative with respect to x of 3x squared plus 5 f of x. We would get 6x plus 5, the derivative of f is f prime of x. If I were to evaluate this at x equals 3, 3x squared plus 5 f of x, I would get 6 times 3 plus 5 times f prime at 3. Okay? Make sure you know your product and quotient rules. So if I have the derivative with respect to x of two functions, say f of x and g of x, that's just f of x times g prime of x plus g of x times f prime of x. We talked about ho d high minus high d ho, so if this is high and this is ho, we have, or sorry, not minus. Let me rewrite it. We have high d ho plus ho d high. We talked about the seven dwarves there in class. And the quotient rule is if I have the derivative with respect to x of f of x over g of x, it is g of x times f prime of x minus f of x times g prime of x all over g of x squared. And if we're labeling this high and this low, that's equal to low d high minus high d low over low squared, where d high or d low is just the derivative of high and the derivative of low. Let's see here. I want you guys to know how to do weird sine cosine limits. So I told you guys I would warn you if this was going to be on the exam. It will be. I think the best way to prepare you guys is to do a full example of this. So this is probably going to be our longest example in this review. Note that the limit as x goes to 0, sine of x over x is equal to 1, and the limit as x goes to 0, cosine of x minus 1 over x is equal to 0. These would be given to you on an exam if we were to ask you a question like this. And I want you guys to find the limit as x goes to 0 of tangent of 7x over sine of x. Actually, let's do tangent of 5x over, ooh, guys, I'm lying. I'm trying to make this complicated. Okay, the tangent of, let's say, 6x over sine of, let's say, 3x. Okay, I like that better. All right, so if I were to do this, I only have these two rules up here to my disposal, so I know I should probably be using at least one of them. I might not have to use both, but I should be using one if they gave it to me. So I'm going to rewrite this in a way that's a little bit more manageable. We have the limit as x goes to 0 of tangent of x is the same as sine of x over cosine of x. So this tangent of 6x becomes sine of 6x over cosine of 6x. And then we still have that 1 over sine of 3x because we have this sine of 3x in the denominator here. Okay, so I'm trying to get this guy to look something like one of these, and I don't really have a minus 1 anywhere, so I'm going to focus on this guy first. All right, so I'm going to try to make this sine of 6x look like sine of x over x. Okay, so I get the limit as x goes to 0 of, if I want it to be sine of x over x, I have a sine of 6x, so it's actually going to be sine of 6x over 6x. But if I'm going to divide by 6x here, I need to be multiplying by 6x in the top so that I'm really multiplying by 6x over 6x, which is just 1. So then I still have my 1 over cosine of 6x times sine of 3x, because these two denominator terms are just going to move down here. Okay, so using this guy up here for the new fraction that we just created is going to give us this guy becomes 1 because the limit of 6x over 6x as x goes to 0 is 1, thanks to the equations they gave us at the beginning. And then we still have the limit as x goes to 0 of everything else, which is 6x over cosine of 6x times sine of 3x. Okay? So first of all, we know that the limit of two things multiplied together is just the limit of the first thing times the limit of the second thing. So I'm going to divide this out a little bit better. I'm going to write this as the limit as x goes to 0 of 1 over cosine of 6x times the limit as x goes to 0 of 6x over sine of 3x, because we can actually directly plug 0 into cosine of x. The reason we can't plug x into sine of 3x is that sine of x is equal to 0 sine of x is equal to 0 at x equals 0. So this would be 0 over 0, which we know is not defined and we haven't simplified far enough. But here, the cosine of 0 is just 1, so this becomes 1 divided by 1 times the limit as x goes to 0 of 6x over sine of 3x. Now if you note, we have another sine of x and an x fraction, which should match up again with the equation we were given at the beginning. So if I go ahead here and rewrite this a little bit, it'll be a little bit nicer. So we can have the limit as x goes to 0 of 2 times 3x over sine of 3x, right? And you might say, well, this is a flipped version of the equation we were given, but we can actually deal with that because this is equal to the limit as x goes to 0 of 1 over, here, let's just pull out, sorry guys. I didn't give myself enough room, and I want to pull out this 2. So this is the limit. We have 2 times the limit as x goes to 0 of 1 over sine of 3x over 3x. Because if we divide 1 by a fraction, it's just that same fraction flipped upside down, if you guys know your fraction multiplication. So then we have 2 times the limit as x goes to 0 of 1 over the limit as x goes to 0 of sine of 3x over 3x. And that gives us 2 times the limit as x goes to 0 of 1 is just 1 because there isn't an x. And then the limit as x goes to 0 of sine of 3x over 3x, because this 3x matches this 3x, we can use our original equation up here. And that gives us also a 1. So overall we have 2. That's probably the most complicated thing I want you guys to be prepared for, so hopefully that made sense and you guys can kind of review problems like that. I believe we did one in class